Look up at the night sky tonight. You will see stars. You will see darkness between them. But somewhere out there, invisible to your eyes, something is swallowing light itself. Scientists call it a black hole, a place where gravity is so strong that nothing, not even light, can escape. It sounds like science fiction. It is not. In 2019, astronomers released the first ever image of one, a glowing ring of fire around a pit of absolute nothing. The world gasped. Newspapers called it the discovery of the century. But your ancestors were already describing something eerily similar thousands of years before telescopes existed, long before Einstein wrote a single equation. Was it coincidence? Or did they see something we are only now beginning to understand? Let's go back. Not decades, not centuries, millennia. In the Vedic and later Puranic texts of ancient India, there are descriptions of cosmic regions where light does not travel. Places described as Gabhodaka, oceans of darkness at the edge of creation, regions where even divine light bends and vanishes. The texts do not use the word gravity. They did not have that word. But they describe a pull, an inescapable pull, at the boundary of the visible universe. Sit with that for a moment. A civilization with no telescopes, no mathematics of relativity. And yet, they were talking about boundaries where light disappears. Modern physics only caught up to this idea in the 20th century. In 1915, Albert Einstein published his general theory of relativity. Within months, a German physicist named Carl Schwarzschild used Einstein's own equations to describe a point where gravity would become infinite. A point of no return. Schwarzschild did his calculations from a battlefield during World War I and died shortly after. He never saw his own idea proven, but he had, on paper, described the mathematics of a black hole before anyone believed such a thing could be real. For decades, most scientists thought it was just math, a curiosity, not something that could actually exist in the universe. Then, the evidence started arriving. In the 1960s and 70s, astronomers detected strange sources of X-rays coming from deep space, objects so dense and so dark that light itself seemed to be disappearing into them. Then, in 2020, astrophysicists Andrea Ghez and Reinhard Genzel won the Nobel Prize in Physics for tracking stars orbiting an invisible, impossibly massive object at the center of our own galaxy. They had spent decades watching stars swing around something they could never directly see. Only its gravity gave it away. Doesn't that sound familiar? An invisible force at the center, pulling everything toward it, described only by what orbits around it. Now go back to the old texts again. In Hindu cosmology, there is the concept of Kala, time itself personified as a devouring force. Kala does not simply pass. Kala consumes. Entire kalpas, entire cycles of creation are swallowed back into an undifferentiated void before creation begins again. The universe is born from darkness, expands, and is eventually pulled back into that same darkness. Physicists today describe something startlingly close to this. Not as poetry, but as mathematics. Every black hole bends space-time so severely that time itself appears to slow, then stop at its edge. Stand near enough to one, and to an outside observer, you would appear frozen in time forever, swallowed by both space and the passage of time simultaneously. An ancient civilization had no way to measure this. So why did they choose those exact words? A force that eats time, a boundary where light cannot escape, a darkness at the edge of creation that eventually returns. Coincidence has a limit, and this one keeps stretching further than comfortable. Let's talk about someone else. Subramanian Chandrasekhar, an Indian-born astrophysicist, spent his career studying what happens when stars die. In the 1930s, he calculated that a star above a certain mass could not settle into a stable state after collapsing. Instead, it would keep collapsing. Forever, his own scientific mentors mocked him publicly for the idea. Decades later, it was confirmed as one of the essential building blocks of black hole theory. In 1983, he won the Nobel Prize for it. An Indian mind doing modern mathematics arrived at a conclusion that unknowingly echoed a much older Indian idea. A collapse with no flaw. A darkness that does not stop. Is that just family resemblance in imagination? Or is there something about staring at the same sky across thousands of years that leads different minds toward the same terrifying truth?
Here's where it gets even stranger. Some ancient astronomical texts, including portions of the Surya Siddhanta, describe regions of the sky where stars vanish and do not return, tied to complex calculations of celestial motion and shadow. Scholars still debate what exactly these passages meant. Some argue they refer only to eclipses and shadow planets, a kind of early orbital mathematics. Others see something more. Either way, the ancient authors were clearly comfortable with the idea that stars are not eternal, that the sky itself has places where something simply stops being visible. You live in an era where we can finally check. In April 2019, the Event Horizon Telescope team, an international collaboration of over 200 scientists, produced the first direct image of a black hole's shadow in a galaxy called M87. Not a drawing, not a simulation, an actual photograph of a boundary where light bends and disappears. When that image was released, one thing struck almost every physicist who saw it. The boundary was almost perfectly circular, a ring around nothing. Ancient depictions of cosmic gateways, devouring, in temple architecture across India are also drawn as circular thresholds. Gateways between one world and the next, often carved with the sun and darkness on opposite sides. Symbol or memory of something once observed and half understood? You don't need to believe every ancient text was secretly a physics textbook. That would be its own kind of oversimplification. But you also don't need to dismiss the pattern outright, because here is the uncomfortable truth science keeps running into. The universe does not care what century you live in. Gravity worked the same way 10,000 years ago as it does now. If a black hole existed near enough, visible enough, to ancient sky watchers, through effects on nearby stars, through gaps in the visible sky, through some observable trace, it is not unreasonable that a highly observational sky-obsessed culture would build language to describe it, even without the mathematics to prove it. What ancient India lacked in telescopes, it made up for in patience. Priests and astronomers tracked the sky for generations, recording positions, cycles, and anomalies passed down through oral tradition long before they were written. That kind of long-term obsessive observation is exactly the method modern astronomy still relies on today. Decades of watching the same patch of sky, waiting for anomalies, waiting for something to move that should not move, or disappear that should not disappear. Maybe that is the real inheritance, not a secret ancient blueprint for relativity, something quieter, a discipline of looking up and refusing to look away, generation after generation, until the pattern reveals itself. Because that is exactly what it took in the modern era too, not one flash of genius. Decades of accumulated observation, mathematics, failed careers, mocked theories, and finally, a photograph. So the next time you see an image of a black hole, that ring of light around an abyss, don't just think of Einstein or Schwarzschild or the Event Horizon Telescope. Think of a civilization on the other side of the planet, thousands of years earlier, staring at the same night sky, reaching for words to describe a darkness that swallows even light and time itself. They didn't have your equations, but they were looking at the same universe you are. And somewhere between an ancient verse about a devouring darkness at the edge of creation and a modern photograph of a black hole's shadow, one question remains. patient as the sky itself. What else did they see that we are only now learning how to prove?